pencils go down and you pick up your colored pen. Everything that you've written is now locked in. You cannot change your warm-up, but you can learn from the experience. So, let's get some people involved right off the bat. To the equity bars we go. And we've got number 10, 11, 13, and 23. Number 10, 11, 13, and 23. Number 10, where are you? Number 10, what did you get? Okay, number 11. There's no number 11. Number 13. Sorry? Just say it so that people like anywhere not within the 1 foot of your desk could hear you. How do you know you did something wrong? I appreciate that, but I still want to hear it. Okay, and number 23. Okay, it wasn't optional to finish or not. You got to finish within the time limit or ask for help or seek your help from your teammates. All right. The correct answer is sales of more than $9,000. If you wrote that as an inequality, then this is the inequality that I was hoping that you were going to write. Now, that's not the only way to do it, but since we've been working with inequalities now for several days, that was my hope. So if you got the question right, great, mark it right, pat yourself on the back. That's a good way to start the day. If you got it wrong, doesn't mean you're a bad person, doesn't mean you did anything wrong, but it means that you now have to learn from your mistakes. So first, we have to identify your mistakes. So I've already given you a clue of what was supposed to happen. Now, there's a detail in my inequality that does not seem to be anywhere in the original question. Can someone point out the detail that's in my inequality that does not seem to be anywhere in the question? Emily? Point 10, right here. Positive 0.10. Could one of my students who's operating at a very high level today maybe help the rest of us out and try to explain where that came from? Oh, we got a whole bunch of people. Okay, we'll start with Melinda and then we'll go over to Jacob. Melinda, what do you think it came from?
The percent.
You're asking me or are you telling me?
No, the percent.
Oh, the percent. What percent?
10%.
Oh, the 10%. This right here?
Yeah.
Jacob, what were you going to say? Yeah, the 10% commission. That's exactly right. See, percents are an interesting phenomenon. Percents are very helpful in our world. I mean, they're in everything. But they come in two different forms. It's the same thing no matter what. There's the percent that we use when we're speaking to each other or writing things like in English. And then there's the percent when you use it to do a calculation. So what I've highlighted here, this and this, for those of you who didn't realize, is the same thing. This is in English and this is written in math. When you punch a percent into the calculator, usually we write it as a decimal. So when you're writing it into an equation, you have to convert the percent to its decimal form and use it from there. So all of my students who got 90 as their answer probably put a 10 there, which is totally reasonable. But now starting today, moving forward, you have to realize that 10% does not mean 10. 10% means 0.10. 20% would be 0.20, and so on and so on. Are there any comments, questions about the percent issue? Ethan? Because 10% does not actually mean 10. 10%, this percent symbol, does anyone know or remember from last year? What does this percent symbol really mean? It actually has a meaning. Aaron? That's part of it. Natalie? That means out of 100. Do you notice? Look at this. If I take this bar and I move it there, and I take this little thing and I move it there, and I take that and I move it there, what do you have? 100. 10% means 10 out of 100. Put that in your calculator. 10 out of 100. 0.10. That's what a percent means. So it's a fancy way of writing a fraction. And the denominator is always 100. That's what a percent is for. Okay? Any comments, questions, other concerns? That was a very good question. Any other comments, questions? Okay, you can see today's lesson is titled Lesson 2-5. Make sure you have that written clearly across the top of your paper. You don't have to write the rest, but that tells you what we are going to be studying today. But we're going to hit the pause button on today. So today's lesson is about solving inequalities with variables on both sides. That title's been across the top since the beginning. But let's review the progression that we've gone through. Let's go way back to the first week of school. We studied equations. Simple ones, one-step equations. From there we built to two-step equations, and then we went to multi-step equations. Then we went to multi-step equations that had variables on both sides. Then from there, we did absolute value equations. So we started very simple at the beginning of chapter 1 and progressed to very complex equations. Then we started chapter 2, and it was like we reset and went back to the beginning. And we just had to kind of take what we knew about equations and apply it to inequalities. And so we started with simple inequalities, one step. And then we went to two-step, multi-step, and now we're at inequalities with variables on both sides. So the progression has actually been repeated. It's the same. We're using the same skills. I've talked about that several times already. So I'm talking about it again today. Solving inequalities with variables on both sides, you use all the same transformations you've learned already. But you have the special rule that must be a flashing neon sign in your mind. So far, I feel very confident that this group has digested this rule and applied it. I'm going to hand your quizzes back at the end of class, and many of you did very well, so I'm pleased with that aspect. But it still applies. It will apply from today for the rest of the year. If you're dealing with an inequality and you multiply or divide by a negative number, you must flip the symbol. That goes for December, that goes for February, that goes for March, April, and May. Just because you haven't done it for months doesn't mean it doesn't apply anymore. Does anyone have any questions about the rule or the expectations? Because we're going to jump right in and do some higher level. All right, so here we go. Example 1, solving an inequality with a variable on both sides. So you see y is less than or equal to 4y plus 18. Again, in your mind, you should be thinking to yourself, well, I know how to solve this, so I'll apply the same process to solving an inequality. Just pay attention to that flashing neon sign. Any comments or questions before we jump in? Good, so I expect that many of you already know what the first step is. Give me a thumbs up if you think you know the first step. And even if you don't, it doesn't mean you're bad. It just means you need to try to catch on. Okay? Christian, what's the first step?
The y that doesn't have a number is line y. And you combine like terms.
Okay, well, what like terms do I combine with it?
1y.
Well, when you say combine like terms, that means that there's another term somewhere to add to it. You're right. We should combine like terms, but are there any other terms over here to combine with it? Okay, so now we go to the next step. What would the next step be? Okay. Well, it'll start to come back to you. Tatiana? Say it again a little bit louder and a little more clearly. Okay, well, what's the real way you want to say it? Subtract y from both sides. Subtract y from both sides. When you have a variable on both sides of an equation or an inequality, you have to collect them onto one side. You cannot solve either without them all being collected. And so subtracting or adding one of them to both sides will accomplish that goal. Now, why did we do the 1y and why didn't we subtract 4y from both sides? What guided us there, Ethan? Yeah, 1y is smaller, has a smaller coefficient. Now, you will get the correct answer even if you do it the other way. If you subtract 4y from both sides, you should still get the correct answer. But this way usually, not always, but usually works out a little easier. So, this cancels out. Did we multiply or divide by a negative number? No, so the symbol's going to stay the same. And now work our way down. Now, this canceled out and I have nothing left on the left-hand side. That means that there's no solution, right? I just stop because there's no solution. I see this all the time. Students are deathly afraid for some reason of the number 0, and I don't know why, but it seems to be a thing. What's y minus y? 0. Write a 0. It's a number, just like any other number. 4y minus 1y, of course, it's 3y plus 18. This does not mean no solution. It means 0. It means exactly what it says. It doesn't mean stop. It doesn't mean you're done. It means finish the problem. So what's the next step? Diane? Very good. You said that beautifully. Subtract 18 from both sides. This now cancels out, which is what we wanted, and now I have 0 minus 18. 0 minus 18 is negative 18. Less than or equal to 3y. What's the final step to finish this out? Deja? Once again, said perfectly. Divide both sides by 3. Did we divide by a negative number? No. Yes, that's a negative number, but when I say divide by a negative number, I'm talking about this number on both sides. That cancels out, and I'm left with, I'm running out of room a little bit, so I'll come over here. I'm left with negative 6 less than or equal to y. And we don't really love it that way. It's still correct, but we would rather it be flipped around. So if we flip it around, Natalie, what will it become? Yeah. Remember, when it's an inequality, you have to flip the whole thing. So this will be y is greater than or equal to negative 6. And that is the proper way to write a solution. That's the algebraic representation. Does anyone have any questions on how we arrived at that? So let's go ahead and graph. We got negative 6, negative 5, negative 7, negative 4, 8. Put a closed circle on the negative 6 and shade everything bigger than it. And I apologize, I was supposed to hand out rulers so you guys could have an easier time with graphs. So let me quickly get rulers out to you guys. That's fine. That's just to help you draw straight lines and to make the tick marks for the number line. So I apologize, I should have given them out before. So, now you have the supplies you need. Thank you. So, any comments, questions on how we arrived at this? All right, so let's continue building on what we know and expanding what we know. Again, there's nothing new here. It seemed like we needed to jog our memory a little bit about the fact that there's variables on both sides, but other than that, you guys know what you're doing. So, how do we attack this inequality? What's the first thing we're going to do? Start with Emily, Natalie, Kianis. Emily.
Subtract 2m on both sides.
Subtract 2m from both sides. Beautifully said. That's the smaller coefficient, so that will usually work out better, but you should get the same answer either way. That will cancel out, and now add down. 2m minus 3 is less than 6. Natalie, you were next, and I'm sure you can tell me what the next step is, but before you do, could you tell me how many steps we have left? You sure? Yeah, she should be sure because she's an expert at it, and so are most of you. You should be feeling level 9 Grandmaster Yoda of two-step equations and inequalities. So Natalie, what is the next actual step? Add 3 to both sides. That will disappear. We get 2m. We didn't multiply or divide by a negative number. I've got that going in my head. So we got is less than 9. And Kianis, what's the last step?
Divide 2 on both sides.
Divide both sides by 2. Did not multiply or divide by a negative number. It's a positive number, so the symbol is going to stay the same. M is less than, and what could we write for that? Go ahead.
4.5.
4.5. Now you could leave it as 9/2. That's simplest form as an improper fraction. But when you graph it, it's a bit of a pain to graph that way. So 4.5 makes a lot more sense when you talk about putting it on a number line. But 9/2 is the same value. It's the same thing. Does anyone have any comments or questions about the process here? So let's go ahead and graph. You could do 4.5 and then 5, or I had a couple of students on the quiz, they went 4.5, 5.5, 6.5, and so on. However you want to do it is fine, as long as the interval is the same distance. So this would have to be 5.5, and I'm going by halves. And that would be 4, and that would be 3.5. And then you put an open circle and shade everything to the left. Remember, interpretation is very important for inequalities. You have to be able to understand that 4.5 is not actually a solution. That's just our starting point, and we're saying everything less than 4.5 is a solution. I had a number of students on the quiz put m equals 4.5. For something like this, they wrote m equals 4.5. And that is totally wrong. I marked that wrong on the quiz. Because m does not equal 4.5. M is all the numbers less than 4.5. That's going to get you fired from your job, so we cannot afford that mistake. If you're dealing with inequalities, you have to be careful. Algebra is about the details. Any comments or questions on either of these? Anything at all? Good. Checkpoint number one. Checkpoint number 1. Let's see how you do on your own. 2 questions. You got 3 minutes to find solutions and to graph them. That's 1.5 minutes per question. see how we did. Let's get lots of people involved today. We are going to start with part A only. Part A only, and we've got numbers 13, 17, 18, and 19. Where's number 13? Where's number 17, 18, and 19? Okay, we're sticking with part A. What'd you get? Okay. Okay, so you agree with Deja. What do you think, Ellen?
X is less than or equal to -2.
So I got 3 people who agree. Aaron?
X is less than
So X is, I don't know what happened there. Let's try that again. X is less than or equal to -2 is correct. And here is the graph. What about part B? Part B, let's see how we did. And we will go with numbers 7, 10, 18, and 20. There's number 7, number 10, number 18, and number 20. Okay, go. Okay. Okay.
T is less than -1.
So I think that's what Tristan said, so you agree here, and it was number 20.
T is less than
We seem to have consensus on T is less than -1. T is less than -1. So Natalie, you made a mistake, I think, on your second step, where you added instead of subtracting. Well, you said 5/7, right? Okay. But look at your second step. First thing you did was added 2t to both sides, right? And then you subtracted 1 from both sides? You did -6 minus 1, and you put -5 or +5. -6 minus 1 is -7. Okay. All right, so I know you did parts of it right. So I know Natalie had an issue, and that's not a big deal. But any other comments, questions, or concerns? Go ahead, Diane. Part A? Okay, so let's take a survey. Give me a thumbs up if you got part A correct. Thumbs up. Good. Let's start with Sean. Sean, what's the first thing you did?
I subtracted 4 on both sides.
Subtracted 4? Okay, so you ended up 4x. Okay, so you should have ended up with 0 is greater than or equal to 3x plus 6. Diane, what was your first step? Okay. And Daniela, did you do the same first step? What was your second step?
Subtracted 6
Subtract 6 from
from both sides.
both sides. That disappears. And we get -6 is greater than or equal to 3x. Go ahead, Diane.
Oh, I just read it, x, 1x.
Okay. So you mean on the left side you put in x?
Yeah.
Okay, but when we subtract 4x from both sides like this turns into 0. We're trying to get that to cancel out and disappear and go to the other side. Okay? Good. Any other comments, questions, or concerns? Okay, give me a thumbs up if you got both questions correct. Thumbs up if you got both correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, or 14 people. Very good. Put your thumbs down. That's 2/3 of the class. That's pretty good. If you got 1 correct, you did great. 2 correct is fantastic. Any comments, questions? So now we're going to build from there and apply it to the real world. So you do not have to write this question. You need to write example 2, and then you need to carefully read the question. We are going to do some work together that will involve a little bit of writing, and when we do that, you will do that as well. Let's start by reading and digesting the question. So you've had a chance to read and digest the question. Let's start with the basics. How many characters are there in this story? How many characters, Von Travius? There are 2 characters. So there's 2 characters that we have to keep track of. So let's talk about how to organize that. And we've done this once before, at least once before. We've got the home cleaning company, that's 1 character. We can use abbreviations to help ourselves. We'll call them HCC. We got to keep track of their information. And then we've got Power Clean. We can just call them PC. And we want to try to find the same types of information every time we do a question like this. The first thing that I usually ask you to try and find is called the flat fee or the flat number. I'm writing that word in the middle because I'm going to look for one of those for here and for here. That's why I'm writing it in the middle. The next piece of information we want to see if we have is a rate that applies to either of them or both of them. And then we want to see what's missing. What is missing from one or both of them? Now, there is a 4th piece, and it's called the total. But usually when there's 2 characters in the story, for now we won't have a total because we're basically going to be comparing the 2 characters. So in the future we'll deal with total, but for now we're not going to deal with it. So now let's go back to the beginning and analyze and try and interpret the home cleaning company. Is there a flat fee that applies to the home cleaning company? What do you think, Isabella? Ethan, what did you think? Yes or yeah? What was it, Isabella?
312.
Yeah, the 312 is called a flat fee because you just pay it once and it doesn't rely on other information. It's not 312 a month or 312 a year or 312 per person. It's just $312 to get the siding of the house power washed. Now let's look to the Power Clean company. Is there a flat fee for the Power Clean company? Aaron, what do you think? There does not seem to be. It's a little hard to tell, but it does not seem to have a flat fee. So there's nothing that we can write here. And I probably shouldn't have done that since it looks a little bit like an X, so let's just put a little line through there. Let's go back to the home cleaning company. Is there a rate that applies to the home cleaning company? Is there a number that is dependent on other information? Shannon?
12.
What did you think, Melinda?
12.
You thought 12 was a rate? What does 12 rely on? It relies on what other piece of information? Each window. So that's what makes it a rate. 12 each. That's a clue right there. So the home cleaning company charges 12 per window. What about the Power Clean company? Keanu?
36.
36. Wow, big difference, right? So that company's much cheaper. $12 a window and Power Clean's $36 a window. Big difference, right? Well, we already have a clue on what's missing. What's missing from home cleaning company? What's the part that we don't know yet? Angela? The number of windows, that's right. The number of windows. And that's also missing from Power Clean is that it's all based on the number of windows. And when we're missing a piece of information in algebra, what do we use to represent it? Mark?
Variables,
What should we use in this case?
W.
W would be great. You can use whatever you want, but when you apply things in the real world, you usually use a letter that stands for the word. So since we're looking for windows, then W starts the word windows. So now we have information that's organized, and now we can form expressions for each company. So let's start with the home cleaning company. What expression could we write to represent the home cleaning company that would take all these different bits of information into account? We've got a bunch of people who know. That's awesome. We'll start with Von Travius.
312.
Okay, Emily, do you think this makes sense to represent the home cleaning company? Yeah, it does. Because if I have 10 windows in my home, 10 times 12 is 120 plus the 312, that's how much it's going to cost to have them clean my home. And now if we look at power clean, we need an expression for power clean. What expression can we write for that company? Ethan? 36W. Very good. So we have an expression for home clean company and we have an expression for power clean. Now let's look at what we're actually asked to do. We're asked to find how many windows a house must have to make the total cost from home cleaning company less than power clean. So right there tells us that. Now we can solve this inequality to find the number of windows that would make it so that the company on the left was less expensive than the company on the right. Any questions? So now we've already reviewed how to solve it. Go ahead and solve. What do we need to do first to solve it? Diane? Subtract 12. Well, if I subtract 12 on both sides, here's what I'm going to end up with. I'm going to end up with 300, because you're subtracting 12. That goes with this number. And then I'm going to end up with a minus 12 over here. So is that really what you were trying to do? So you're missing something, and you're on the right track, but you're missing an important piece. What is he trying to say? Milan? You have to subtract 12W because the W is part of the term. And you have to subtract 12W from both sides. That's what makes this disappear, not subtracting 12. 12 would get subtracted from this number. So we end up with 312 is less than 24W. How do we finish that out? Angela? Divide both sides by 24. And I'll finish over here. And we get what? Sean?
13 is less than W, but
Yeah, and so what would be a better way to write it?
W is greater than 13.
That's right, very good. W is greater than 13. And now we need to put it into words that actually make sense to humans. So the question was, how many windows must a house have to make it cost less? So now we need to say more than, I messed it up. More than 13 windows. That's interpretation. That's the most important part about inequalities, is that they require interpretation. This is great, but this tells me that you understand what it means. Any comments, questions on how we went through this process? We read carefully, we pulled out information looking for specific pieces, put the pieces together into expressions, and then formed an inequality, solved, and interpreted the answer. Ethan?
Do we have to give a slide for specific, or can we just
I'm sorry, were you asking, you said,
do we have to do that
No, this is a training wheels technique. So this is something that is meant to come off eventually. But here's my rule, and this is my rule for pretty much everything. If you have success every time, then I don't really care what you do. But if you fail, and I don't mean fail as in get an F, I mean fail as in you get the question wrong. If you're failing often, then you have to change what you do. You have to change your approach. So if you're getting every question right, then I could care less if you do this. If you're getting questions wrong, then you need to do something like this to help yourself. Does that make sense? Good. And that was an excellent question. All right, so let's see how well you can apply the idea to real world on your own. So we've got another real world scenario. Read it, interpret it. You got 3 minutes. All right, let's get some new people involved if possible, but remember all the bars go back in each time, so it could be the same people again. And we've got number 1, number 12, and number 18. Number 1, 12, and 18. Number 1, what'd you get?
F is greater than 160.
Okay, where's number 12? Where's number 12? Oh, there's nobody here? That's you then. Okay, where's number 18? Okay, go ahead, Emma.
F is greater than 160.
So everybody thinks that F is greater than 160, but putting it into words, you would say more than 160 flyers. More than 160 flyers demonstrates interpretation. But you were right, f is greater than 160. I have a typo here that I need to fix. I accidentally put f is less than 160. It is supposed to be f is greater than. Let me fix that. And then, what was the inequality that you used to solve that? Let's see who my confident students are. Go ahead, Gloria, what'd you put?
24 plus 20 times f less than 25.
That was exactly what I had. Very nicely done. Comments, questions, concerns on this? Give me a thumbs up if you got it right. A lot of success. Give me a thumbs up if you got it right without having to write down the information like we did. Good. So you took the training wheels off. Good for you. Put your thumbs down. We're going to finish out today by elevating the level of work that we're doing and looking at some high level inequalities. Upon looking at this, something should have jumped out at you right away. What jumped out at you right away, Milan? Say it again. Yeah? That should have jumped out at you. And so you guys have gotten very good, as I hoped you would. You've gotten very good at recognizing that's got to be done first. So we distribute. Always simplify as much as you can before you begin solving. So we end up with 2k minus 6 is greater than 6 plus 3k minus 3. But here's where I still have too many students, and I don't know how many there are, but I still seem to have too many that are falling short of my expectation. Because we're not done simplifying, and I have a lot of students proceeding from here solving. When I say solving, solving is when you use transformations like subtract 6 from both sides. That's solving. And I can't tell you how many times I see this, and that's where you're going to start messing up. We're not ready to solve yet. Could someone tell us why we're not ready to solve yet? Oh, we got a whole bunch of people. No, good. So we go ahead, Daniela.
To combine like terms.
What are they?
The numbers of the
Okay. In this case, what are they?
numbers
Specifically.
6.
Yeah, the 6 and the negative 3. Very good. Those are like terms. You have to combine them before you start solving. That's still part of the simplifying process. Remember that mantra from the first week of school, simplify then solve? 2k minus 6, excuse me, that's not a very good 6. 2k minus 6 is greater than 3k, we didn't touch that, and now combine like terms, plus 3. Now we are ready to solve. Now we just spent a whole bunch of time going over how to solve from here. I don't think we need to spend time again. So let's just quickly finish this out. This is the smaller coefficient. Subtract it from both sides. Have to include the variable because we're trying to make that cancel out. Here's a danger zone to beware of. That's a negative 6. Make sure you write negative 6 is greater than k plus 3. There's actually only one step left. My really high level students could probably figure it out without even doing the last step. Subtract 3, subtract 3. At no point did we multiply or divide by a negative number. So we end up with this. As Sean explained to us earlier, we want to flip that around so the k is on that side. And here's what we end up with. Of course, we graph. But again, we don't really need to spend time discussing it. We just do it automatically. Anyone have any questions on how we did this? Any comments, questions, any concerns? Any issues at all? So we're going to finish out the day doing a couple of challenging ones on our own. You got 2, so that you can think of this as kind of a little wrap-up quiz to see how well you digested today's material. You've got 2 questions. You've got 4 minutes. Solve each and graph. All right, pencils go down, colored pens come up, and let's see how we did. For part A, we got numbers 5, 11, 8, 11, and 22. Number 5, number 8, number 11, and 22. Number 5, what'd you get for part A? Part A?
R is less
Okay. Number 8, what'd you get?
R is less than or equal to
Okay. Number 11.
R.
Okay. Number 22.
R is less than or equal to
Okay. So we have a little bit of disagreement. R is less than or equal to positive 2. And that is what your graph should have looked like. And part B. Let's see who we got for part B. Part B, we got numbers 5, 12, 15, and 20. Number 5, 12, 15, and 20. Number 5. Okay. Okay, so we have a big disagreement. Number 15.
X is less than 3.
Big disagreement. Number 20. Big disagreement. So we've got x is less than 3. And that is the graph. So, I do need to spend time on part B since we had such a huge range of answers, but I am just about out of time, so I'm going to have to squeeze that in next time. So, draw a line across your paper. Your homework is on page 97. You're doing numbers 1 through 13. And on page 98, you're doing numbers 1 through 4. That's 17 questions. And next week, you're going to have a test on chapter 2.